Hello and welcome everyone. Today I would like to talk about operation management, a new topic in MBA. And what I mean by that, if I have any system, this is the system that I have. Could be a hospital, any organization, a hospital, a shop, whatever. I have inputs and I have outputs. The inputs, everything that actually participate in the system, like people, money, labor, machines, materials, information, etc. Okay, the outputs of this system, and it could be any system, which is the product and the service, which there is of course a difference between them, and the patient's experience. Okay, so in between the input and the output, I have the transformation, which could be manufacturing, logistics, processing. Okay, so in operation management, I should understand what is the inputs and outputs of my system that I have, whether it was a hospital or anything else. So there's something called process design. How workflow, simply. So think about it. This is a shop that sells ice cream. Okay, this is an ice cream. So it's simply, the design would be, people will come here, this place, they will pay, then they will receive the ice cream, then they're gonna leave. Okay, this is actually a chart. This is the process design. Okay, anything, of course, could be more complicated, but we should understand and we should put the design of how work will flow. Okay, there's also the concept of capacity planning, how much we can handle. Okay, so this is a hospital, for example. We have 100 bed. We have 10 clinics. We have 10 doctors. We have whatever. Okay, so of course we should calculate that to know how many patients we're gonna welcome every day. Okay, so we could give a decent service. This is also very important. So also, now I would like to jump to one of the biggest topics in management, which is lean management. It simply says anything that doesn't add value is a waste. Okay, and we should get rid of it and make it approximately zero, as close to zero as possible. Types of waste, according to lean management theory: overproduction, waiting, transportation, over processing, and motion defects. Okay, those are the types of waste that I should try to get rid of in my business. Think about it. I'm manufacturing medical gloves, okay? Now, of course, they should be sterilized, but I'm sterilizing them too much, more than it should. This is actually a waste. This is over-processing waste, okay? Or think about it, I have workers that live in place A and work in place B. Instead of just, being the bus goes from A to B, it goes A and all over, then B. This is a waste also. Makes sense, of course. This is motion waste. Or if I have in the hospital, the nurses or doctors, physicians, they're moving too much in the hospital. This is a waste. Motion waste. Why is that? Because maybe for example, they have to use the bathroom. Okay, this is the bathroom. And they're working here. And instead of just having a near bathroom, the bathroom is far away, so they have to move a lot. For example, if they have to drink water or something like that. This is a motion waste. Okay, people are moving more than they should. Okay, of course, this is something wrong with the design itself. So this is what lean management says. There's also a very important concept, which ends as Six Sigma. Okay, it says that reducing defects to near zero. This is what is all about Six Sigma. Think about it. I have a medical lab. Okay, this is the lab tests that I have, the tubes, and some of them, of course, each one has a label. It says the number, the patient's name, etc. Okay, so imagine if I have a wrong, or I don't have a good labeling system that makes those tubes sometimes mixed up together or be lost. So I have to redone and in the medical procedure again. This is a waste of money and time, okay, and labor. So make sure that I solve the problem by, for example, redesigning the labeling system in a standardized way. So I know like patient's name, number, date, blah, blah, blah. Okay, something like that. So instead of redoing 12% of the tests, I would just like do 1%. Imagine how much money I'm gonna save, how much labor, work, time I'm gonna save by just solving this problem. And they could apply this principle Six Sigma everywhere. Also, bottleneck theory. It says that any system, the slowest part, if we solve it, everything will be more smooth. Okay? So sometimes the bottleneck could be too much papers. Or imagine I have 3 doctors, radiation, working radiologists, okay? Doctors who work with radiation. And I have only one X-ray machine. And 3 doctors have to use only one X-ray machine. So this is, of course, gonna make patients wait, gonna make doctor wait. This is terrible. So the bottleneck here is the X-ray machine because I only have one. So increase the numbers of X-rays machines and you're gonna solve the problem. Okay? Also, good scheduling. This is very important, of course. The design of the building also plays a big role. I already talked about this. So simply the goal of operation management is deliver the right product or service at the right time, at the right cost, with the right quality to the right people. Simply we could define it like this. Okay? So in lean management, simply do more with less, remove anything that does not add value. For example, as I mentioned, patients waiting for 2 hours, nurses walking back and forth due to a bad design, too many gloves in storage. So no, I want to store a lot of gloves. I'm gonna sell or gonna use what I have. When I'm about to run out of gloves, I'm gonna order again. Something like that. Small details gonna make a big difference. And Six Sigma is, you could define it as the art of reducing errors, okay, in your system. And reduce the defects to near zero. So it uses solutions by actually solving things that you have. Small details can make a big difference and could make the whole system go a lot better. So Six Sigma, actually, I want to talk more about it because it's very important. It has 6 steps. Okay, this is Six Sigma, still talking about it. It says if you want to use this method correctly, I have to apply 5 steps. First, define the problem. What's the problem? I'm actually, for example, I'm redoing a lot of medical procedures, or there is a lot of defected products in the line, or anything like that. The second step of Six Sigma, which is measure. So, measurement. We do that by actually collecting data to know exactly what we're looking at. what is the problem. So I would, as the medical procedure example that I gave, I have noticed that we're in the hospital repeating 12% of our medical procedures. So I know there's something wrong with that, okay? Thirdly, which is analysis, to apply mathematical principles, try to understand more the situation, then actually improve. Because you could determine what's the problem, you could solve it. And the fifth step was to control. After you solve the problem, make sure it doesn't happen again, okay? So you change the system, you change a part of it, and just make things that more smooth, and you could save money. Also, the Toyota production system. It's a famous company, of course. It's a famous company that produces cars. Toyota, everybody knows it. So they have theory in management, actually. The first principle says it's just in time theory. What it means that produce only what is needed when it's needed. So think about a company that manufactures cars, and of course there's a lot of parts that is added into a car. You have windows, you have the engine, we have whatever. So don't manufacture more than you already need, okay? Produce only what is needed when it's needed, okay? And there's another principle also, is to stop the process when there is a problem. When you notice there's something wrong, shut down the system entirely, temporarily. Okay, to figure out what's the problem, to eliminate the loss, okay, in money and work and labor. So you make sure that when you work, you're working actually worth it. Also, it says that small improvement lead to big differences, as we saw before in our examples. So also we talked about bottleneck. It has a similar principle that sometimes there's something specific that is wrong with the system, and when you solve it, the whole system will be improved. So this is also so now I'd like to talk about a new topic, actually, or probably I'm gonna make another video about data analysis in a separate video. All right, goodbye.